We'll next introduce another sorting algorithm, which is called quicksort. Quicksort is a very fast sorting algorithm in practice. In fact, it's one of the preferred sorting algorithms out of all the ones out there. This is extremely useful in some programming languages such as C++. The average running time of the algorithm is O of n log n, so on average it's already just as good as any of the other sorting algorithms we've talked about, at least some of the better ones. And the reason why it's fast is because it has a very tight and highly optimized inner loop. And we'll see that algorithm a little bit later on, but we'll see that the way the loop is set up, it's very tight, it's very efficient. Now, we say that the algorithm is O of n log n in the average case. If we do not implement this correctly, there is a possibility that we can get an O of n squared time algorithm for the worst case. However, as I said, if we do this correctly, there is a very, very small chance, so it's a very unlikely chance, that we would get the O of n squared bound. So with a little bit of effort, we can get something closer to the O of n log n bound that we want. And also, like merge sort, quicksort is a divide and conquer recursive algorithm. So we will be using recursion, we will be splitting up the array into smaller parts in order to solve the problem. We'll start by going over a simple sorting algorithm. So we're going to just arbitrarily choose any item in our array, and then we're going to form three different groups. One group is going to contain all the elements that are smaller than our chosen item. We'll have another group of all of the elements that are equal to the chosen item, and then our third group will be all the elements that are larger than the chosen item. What we'll then do is recursively sort the first and third groups. We don't need to worry about sorting the second group, but we'll recursively sort the first and third groups, and then finally we'll concatenate the three groups. Let's take a look at the code for this sorting algorithm. So I've already implemented this for you, so we're just going to look it over, and you can actually get the code online so you can follow along and see what's going on here. So just like with our merge sort algorithm, I have everything in one file. We don't have a class file and then a client file. So our main method is going to create the list and call the appropriate sort method. Now I want to mention here that we're going to use the array list collection that is provided by Java. We're not going to use the myArrayList class that we had before. We're just going to use the one that's already provided in Java. And that's why our type here is going to be list instead of ArrayList. So it's list, we're still using integers, but then we can create an object of ArrayList. And notice I didn't put integer here. That's perfectly fine the way we're doing this. We don't have to put the word integer in here. So we're going to add several things to the list. We're then going to call the sort method. We'll take a look at that in just a minute. And then we're going to use a for each loop to look at each item in the list. Because remember, since we are using an object of the list, we can't really assume that we have a get method. We can't assume that we can just directly access it because we're dealing with the Java collection. But we can use a for each loop that will take care of it. So that's the item is actually stored in I, and then we print it out. So that's how we're handling getting each element in our list. Now let's take a look at the sort method itself. It's pretty straightforward. So as long as the size of the list is greater than 1, because if it's 1, then it's already sorted. So we're going to create our three lists. So one called smaller is going to be all the elements that's smaller than some item that we choose. Same is going to be all the ones that are equal to the chosen item, and larger is going to have all the items that are greater than the chosen item. So here, our chosen item is going to be the middle element. So we're going to pick whatever the middle element is, and that's going to be our chosen item. So then we're going to use another for each loop right here, and we're going to compare each element in our list with the chosen item. So we're going to put all of our items on our list in the appropriate lists. So all the items that are less than chosen item will be added to the smaller list. All the items that are greater than the chosen item will be placed in the larger list, and those that are left over, which are the same as the chosen item, will be added to the same list. We'll then recursively sort these smaller and larger groups. We don't need to sort the same group. It's all the same thing. There's no point in sorting that. So we'll sort the smaller list, and then we'll sort the larger list, and then we're going to add all 3 sorted lists into our items list. So how do we do that? Well, we're going to call the clear method from our items. Remember, items in this case is our array. We see that is what's being passed in our sort method. So we cleared. So then we're going to add everything from the smaller list. At this point, smaller is completely sorted, so we can do that. We then add all the items from our same list, and then we're going to add all of our items from our larger list, which is also sorted. So that means everything in our items list will be sorted. So let's actually compile this and run it and see what happens. So we'll compile. No compile errors. And let's go ahead and run this. And sure enough, we do see 1, 2, 13, 15, 24, 26, 27, and 38. So this sure enough does sort all of our items by doing this, partitioning the elements into different lists and then sorting them recursively.